what I want you to think about in this video is that there are lots of ways to answer these problems with multiplication, but no matter what approach you take, we're going to get the same answer. So I want to take this same problem, 32 times 46, and I want to complete this in two ways. Some of you have seen and are very comfortable with thinking about this as an area idea, that you have 30 and 2 by 40 and 6. And then you just find the area of each part of the rectangle and then add those up to get to the answer, the product. So 3 times 4 is 12, and I have my 2 zeros, so 1,200, because this is 30 by 40, so the areas, those two lengths, multiplied. Here I have 2 by 4, so 40 times 2 is 80 for the area of that section. Then for the next section, you have this length is 30 and this width is 6, so it's 30 times 6, or 180. And then this last part here has a length of 2 and a width of 6, so the area here is 12. So obviously this is not drawn to scale, but the area of the whole thing then is going to be adding 1,200 plus 180 plus 80 plus 12. So if I combine all those, I get 2, I get 16, 17, carry the 1. That's 3, 4. I get 1,472. Some of you may instead want to use the algorithm. And then I have 32 times 46. So I'm just going to take the 6 and multiply it to each piece here, because it is 6. So 6 times 2 is 12, carry the 1. 3 times 6 is 18, plus 1 is 19. That 192, just so you see this, is the same thing as this 192 when I put those two things together. 180 plus 12 gives us the 192. Same exact thing. Now what I'm going to do is I'm going to erase what I carried before because I don't need it anymore. And this time I'm going to instead use the 4. I need to multiply the 4. The thing is that this is not 4, it's 40. So because this is 40, if I multiply 40 times 32, it's going to end with a 0. So I put this here because I'm not in the ones place anymore, I'm in the tens place. I've got that times 0 with the 40. And then I just repeat the process. 4 times 2 is 8. 4 times 3 is 12, 1,280. I just want you to see in the area model, it is the area of those two top rectangles there. Okay, now I'm going to add all these two lines here. And I get 2, 17, carry the 1, 4, and 1. I get the same exact answer. I get 1,472 or 1,472. And I do not care which way you do this, and you only have to pick one way. What we're going to do now is take that same problem we did on the last slide, the 32 times 46, which I already know the answer, and I'm just going to change the problem just a little bit. Well, a lot. So I'm going to say instead 3 and 2/10 times 46. The amazing part is if I do the math again, I'm still going to get these numbers, 1, 4, 7, 2. But this is what I'm going to ask myself, what makes sense? So we're going to go back to with the estimating skills we've been working on too. 3.2 is about 3. 4.46, is about 50. I would expect my answer to be 3 times 50 is 150. So in order to get this answer to be around 150, I have to look and ask myself, where would I put my decimal? So I'm going to say, if I put it at the end, I am at 1,472, which is just too big. If I have it here, I'm at 147.2, which is really close to 150. So that's my answer. I'm going to give you another one. Instead, if I did 0.32 times 46, I'm going to estimate this again. And I know the numbers are still going to be 1472, the digits in my answer. So 0.32 is less than 1. I'm going to put 1 just for the sake of argument here. I'll even put less than 1. And then I know that this is about 50. So even half of 50 would be, like if this were half, then I would say half of 50 is 25. And I know it's even going to be less than that. So let's look at options where our decimal could be. Again, if it's here, 1,472. It's too big. If it is here, that's 147.2. Again, it's too big because we know it's going to be less than 25. If it's here, it's going to be 14.72. I'm going to show you something else. This is another way. So you can, every single time, you can say to yourself, what are the numbers, which you can figure out, and then about where is my answer going to be by using estimation, and then put the decimal in. Or what you can do is you can instead say that if you have here if you instead have you have one number behind your decimal here, one digit, and you have one digit behind your decimal here. Here I have two numbers behind my decimal, so my answer has two numbers behind my decimal. Let's look at one more, just so we can see that this still works. Some of you are going to really like this way a lot better, which is great. All right, so let's say I have 0.32. Oh, sorry, let me change that. I'm going to instead say 3.2, or 3 2/10, times 4 6/10. Again, I know I still get 1472 every single time. So let's use the second way. I have one number behind my decimal here, one number behind my decimal here. That means I'm going to need to have two numbers behind my decimal here, and I'd put it right there. Just to sort of do the estimation way to see if this still works. 3 2/10 is about 3. 4.6 is about 4 6/10, is about 5. So I would want my answer to be around 15. And 14.72 is really close to 15. So you have a couple different ways to do this. First, you just go through, just multiply. And you have those two different models. Then you can either use this estimation way of about how much is it going to be and then decide where to put your decimal. Or you might say instead, you want to count up the total number of digits behind the decimal, make sure that the same number are in your answer. Okay, see you in class tomorrow.